Hello everybody. Now I will make a tutorial about Codeforces Round 933 Division 3. Let's start with the first problem. Rudolph and the ticket. In this problem, they will let us use and k. We'll have the array. We will have the array with n integers and another arrays with m integers. Okay, so and they need us to count how many ways to select indices f and s such that bf plus cs is smaller or equal to k. We'll have the first array is b1, b2, b3, b4 to bn, yeah, and the second array is c1, c2, c3, c4 to cn, and we need to count the indices fs such that bf plus cs is smaller or equal to k. So we need to count how many ways to do this one. And for this problem, we just need to iterate over f over every f that we can iterate and over every s. So the complexity of this is O M O N times M for each test case and base t test case. So the final complexity is O T times N times M. Okay. This is the code of for the first problem. Okay, I iterate over every f and every s, and I just count it. Okay. Okay, let's move on to the second problem. Root of n 1 to 1. So in this problem, they will let us an array a1, a2, a3 to an, and they ask us that is it they will have one operation. The operation is we need to operate this operation. We choose I, and then we will for ai we minus this by 1. For ai plus 1 we just minus this by 2, and for I minus plus 2 we minus this by 1. And they ask us, is it possible to make the whole array that they gave us to 0? Okay, let's choose an example. Okay. 1, 3, 5, 5, 2. Okay, we can make this array to 0 by the first operation is here, so it will become 0, 1, 4, and 5, 2. Okay, this is the first operation. In the second operation, we will operate in this, so it will become 0 0 2 4 2, and in the third operation we will need operate here 0 0 1 2 1. And the fourth operation will become total 0. Okay, so we can see that this array we can make it into totally 0. It's for 0. Let's check with another array. This array 2 2 okay 2 4 4 5 1. Let's check. We can see that it's not possible to make this array into totally 0. Let's check. We add this 1, make this into 1 2 and 3 5 1. A second, choose this one, it become 0 0 and 2 5 1. 3, it become 0 0 1 3 0. And in the fourth, we can see that we cannot operate any operations right now in this array, so it's impossible to make this array into 0. So how to solve this problem? Okay, so for this problem we just need to iterate we just need to iterate from right to left. Needs to iterate from right to left of the array, and we operate that operations until the whole array becomes 0. And if we cannot operate the operations anymore, so that array is impossible to make it all elements to 0. Okay, like 0 1 3 3 1. So we just need to iterate these arrays. We can make the operation in this from left to right, make the iterate from left to right. So we just make it 0, make it this one become 1 and 2 and 1. We can see that this subarray we can apply the operations. So it will become 0 0 0 0 0, and this is the result. So we can see that this array we can make it to totally 0, and that's the end of the problem. And this we have a time complexity of O(n). Let's move to the third problem, Rudolph and the ugly string. In this problem they will give us a string. Example, MAPP. This is the string that they gave us, and they define that the ugly string is the string that contains substring map or pi and order is beautiful string. Okay, and they ask us in one operator we can choose I, and we will delete character as I from the string. Okay. For example, we choose I is equal to 1, so it's here. So we will remove this character and it will become MPP. Yeah. So we have an example. With this string MMAP MMAP and a pi. So the minimum operator that we can apply to this string to make it beautiful is we remove this character and this character, so it will become MMP and APE, and they does not contain any substring that is equal to map or pi. We just remove it from the string. So our strategy in this problem is we will check, like in the string, let me have an example, MAPIIPIE. So we will check it in here. If it's not MAPIE, so we will just need to remove the center character and we become MPIIPE, and check here. If it's not in the center character, it's not this string, we just need to remove the center character in the band substring. It will become MPIIPE, and there's no ugly substring. So if they are MAPIIE, so in this case we need to remove the center of the string, which is P, and it will become MAIE. If we remove A, I, or E, M, it will become M. Let it example, we remove A, it will become MPEIE, and we will still have PIE. It's not good, and we will need to use two operators, and it's not good. This one only use one operator, and this one is better. Okay, so the time complexity of this algorithm is O (n), and this is my code. I check if they are MAPIE, and I add it, and I iterate over it, and I know that the answer increased by 1, and I check if they are MIP or PIE. So the answer is also increased by 1 too. So it's the end of the problem 3. Okay, let's move on to the 4th problem. Rudolph and the ball game. It's a bit slow here. Okay. In this problem, they will show to us a circle with number here. Okay, and they will have n numbers here, and they have m operators. Okay. In one operator, they can be either in the clockwise here, or counterclockwise. Okay, and they will show us an x number. They will show to us an x number, which is the distance of the operator. Well, what's the distance? The distance is here, the distance of from this number to this number, and it depends on the way the is clockwise or counterclockwise. The distance of this is 2, but this answer is 2. So in one operators, they will show us 3 things. If it's missing, so it can be either clockwise or counterclockwise. If it's 0 is clockwise. If it's 1, it's counterclockwise. Okay, and from this number, we will measure the distance. We will throw a ball from here to the distance, and they ask after m operators, where will the balls go from here? If 2, it can be either go to here or go to here. Okay. For example, this problem. If it's, we have this example. Four, 5, 6. Okay. They show to us that they can be operation with x number 2 and is missing, so it can be clockwise or counterclockwise, and in the second operator is also be 2 and missing. So it can be from here maybe reverse to here or here, or this number can be to here and here, and so on. Then we have 1, 3, 5, and in the last operators it can be is 2 and missing again, and it will come from here to here, here, or from here to here, here, and from here to here and here. Okay, it's done. Okay, so the algorithm that I use for this problem is just I just save the whole number that it can be is in after I operators, like here 1, 2, 3, 4, 5, 6, and here, so it will become, and in after the first operators we will have 3 and 5. Okay, in the second operators they will like go like this, right? 5, and this will go like this. So after the second operator it will be 1, 3, 5, and in the last operator they will do it again, so it will become 1, 3, 5. Okay, so in this algorithm I will only need to use the complexity of n times m. Okay, and it's passed. Okay, so this is my code. Okay, I have the cur, vector cur and vector next. It says equal to is missing, so I will put the next. We have clockwise or counterclockwise. Counterclockwise, I just use the formula that r times counterclockwise is n minus r times clockwise. Okay, this is the formula. And next we push back the clockwise here, and we push back another clockwise, counterclockwise here, and we check. We save the whole set of this, and we just see out. We just output the whole thing in the current vector. Okay, so it's done. Okay, we'll move on to the fifth problem, Rudolph and K bridges. Okay, so in this problem they show to us on a river that have the depth, and they want to move from this river bank to the other side of that river bank, and we will need to make some support here, and the distance of those support is no more than d, and they want to build K bridges. Okay, so if we have a support here, we will make a bridge from this bank, river bank, to another bank. and the distance of the support is no more than d. You can say d here is 4, from here to here is 4, and from here to here is 4, so it's no more than 4, right? So, and we choose this one, and this one. So the cost is calculated here. To cost of installing a support in cell Ij is Aij plus 1. Cost here is 1, cost here is 2, and cost here is 1, 2. So the cost to build a bridge here is 1, 2, 1, and it's 4. Okay. And yeah, like we have the array here, and we just need to dynamic programming it. Let's see. Okay, I just build a I just write how to build a bridge in the I row. So let's example is okay. Simple with this 3 3 0, and the d is 1. This is equal to 1. So we will support here, and support here, and the cost is 1 4 1, and the cost to build bridge in this row is 6, right? So the algorithm that I use is dynamic programming with this formula dpi is equal to mean from dp I minus d minus 1 to dp I minus 1, yeah, and plus with ai minus plus 1. The cost here, right? So the mean cost in the other side of the riverbank is dpm, and we will collect all dpm from this is the first row, the second row, the third row, and the fourth row, and we have here 6. This here is 4. Here the minimum cost is 4. Here the minimum cost is 4 2, and this here is 6, and they wanna build K bridge is 2. So it's here. Okay. And with this formula we can use segment tree very easy, and plus with this one. So after we have the dpm array, okay, just like write it down 6 4 4 6, and we need to build k consecutive bridges. So this is the subarray that we need to think about. So the formula for this, we will use perfect sum. So 6, 10, 14, and 20. And this formula is this minus this f I minus f I minus k. Right, and we will check the minimum of this formula. Okay, so it's done of this problem, and this is my code. Okay, I make a vector for I, like a empty vector. Okay, I update for the symmetry. I get for the symmetry, and I get the mean value for each bridge, and I use perfect sum, and I check the minimum cost here, and I output it. So it's the end of the 5th problem. Okay, now we move to the final problems, Rudolph and imbalance. Okay, in this problem, we will have the I array and the D array and F array, and they ask us to add at most one problem. We will choose I and J, and we will add problem with complexity Di plus Fj, and we have, this is the complexities of our initial problem, and we'll add one problem to it, and the imbalance of the set is the largest value of I minus I minus 1. Okay, so we will need to determine what is the minimum value of imbalance that can achieve by adding at most one problem. So for this problem, I will use binary search. Okay, I will use binary search to searching for the minimum value. Value. Okay, so let x be the minimum value that we want. So how can we check x is, how can we check x is possible? So we will check for each ai minus 1, is it larger than x? If larger than x, we will count it. Okay, and if the number of index I minus 1 is more than 1, so it's impossible for x to satisfy the condition. So if it's only one index ai minus 1 is larger than x, so how can we determine how can we check x is possible? So here, let us say I is ai minus 1. We have problem here, and ai, so we have an x value that x minus ai minus 1 is smaller or equal to the x value. Let us say this one is z, and ai minus z is smaller than x. So we will make some change here, and it will become z is smaller than x plus ai minus 1, and here z is larger than ai minus x, right? So we have the final form is x plus ai minus 1 is smaller than g, and z is smaller than no. The correct form is ai minus x is smaller than z is smaller than x plus ai minus 1. This is the correct form. Okay, and we will searching for this z from this D array and F array, and it's easy with binary search. So this is my code. Okay, so I sort D and F, and I check for each value for binary search. I put it here. I have a range for the I check if the range from L is larger than R. It's impossible to get X, and I make two binary search here, and I check if the left or the right is not possible, so I continue, and if left is smaller or equal to right is absolutely true, so I return true here. If nothing happens, I just return false. Okay, so it's done with problem F. If you like my video, please subscribe my channel Algorithms Helper. In here, we're aiming to provide educational videos about algorithms. If you like any video that I posted, please click on the like button. This will encourage me so much, and thank you very much for watching my videos.